Hey guys, this is Kenneth and today I'm going to discuss IC packaging. So what is the process of making an integrated circuit packaging? So usually fabless designs the chip and then foundries manufactures the design, while the OSATs or outsource assembly and test companies do the packing services. But the integrated device manufacturers or IDMs do all the work. They design, manufactures, and do the packaging as well. The following are the examples of IC packaging: the single die packaging, the system on chip, the multi-chip module, the system and package, and the system on package. But before this packaging, there are several traditional integrated circuit packaging like pin through hole. And under that is the dual inline package with 4 to 64 pins and invented in 1964. And the other one is the single inline package, which is very similar to the dual inline package. The next one is the surface mount technology or SMT. It is easier and faster automated assembly. And under that is the quad flat package, which have higher number of pins and have several types, which are the plastic QFP, the ceramic QFP, fine pitch, heatsink, and low profile QFP. The next one is the pin grid array, and the several types are the plastic PGA, the ceramic PGA, the flip chip PGA, the staggered PGA, and the organic pin grid array. Lastly, the ball grid array, which are the plastic BGA, ceramic BGA, tape BGA, and super BGA. Now let's proceed to silicon interposer. Silicon interposer is the silicon layer between substrate and dies. And the advantages of silicon interposers are high wiring density, thermal expansion to silicon die, lower cost of active devices, excellent electrical and thermal performance, and the possibility of integrating devices into substrates. Silicon interposer can be active, which acts as interconnection, provides communication, and has fully functional chips embedded in the silicon substrate. And it can be passive, which act as interconnection, and it provides communication among dies with no active substrates. So now let's proceed to the structure of silicon interposer. So silicon interposer has a through silicon vias, which is the vertical pathway through silicon interposer, and the redistribution layer or the RDL, which is the horizontal pathway through silicon interposer. And lastly, the underbump metallization or UBM. It is the thin pad connecting the solder bump and the copper in the redistribution layer. Next in line is 2.5D and 3D packaging. 2.5D and 3D packaging are simply subcategories of system and package, or also known as IPs. The 2.5D packaging introduces the silicon interposer and the through silicon vias technology. It integrates the chip horizontally on the interposer, which connects the chip and the die. The die is flip chip pin grid array. On the other hand, the 3D packaging. It mounts 2 or more die on top of each other, which is the active interposer. It's stacked vertically on interposer at an increased functionality density. And it uses memory chips or 3D stocks. The packaging manufacturing process. We have the interconnection techniques. Number 1, the wire bond. It's the most cost-effective and has 4 bonding techniques, which are the ball bonding, wedge bonding, bump or stud bonding, and thermosonic bonding. Number 2 is the flip chip. The ICs are created on the wafer, the pads metallized on chip surface, and then deposited dot solder on pads. When the chips are cut, it is flipped in a line. There will be refill to complete the connection and underfilled the chip. Number 3, the interposer. The manufacturing process are photolithography, etching, oxidation, deposition and filling, chemical metal polishing, RDL fabrication, and backside processing. So now let's move on to wafer to panel level packaging. So it increased performance level, reduced cost, and easier die testing. So now we have a wafer level packaging. It creates package while being part of a wafer and establishes standardized process. So there are 2 types of wafer level packaging. The first one is the fan-in WLP with a full packaging done on wafer, and resulting package is a chip scale packaging, and the fan-out WLP with the wafer is died first and the package is bigger than the die. The next one is the panel level packaging. It is a fan-out packaging on a large square panel. It is the evolution from fan-out wafer level packaging, but in a more complicated one. It uses new technology with lack of standardization process. That would be all. Thank you.